share more about, can you do some self-introduction about yourself?
Yes, my name is Chi-Hwa Wang. I did my bachelor degree in chemical engineering from National Taiwan University, and I proceeded to get a master degree in biomedical engineering at the Johns Hopkins University, and finally PhD degree in chemical engineering at the Princeton University. So I joined the department in the end of '95, so I think I've been in this department for about 20 years.
So what area do you do the research in?
Yeah, for my research area, I largely work on two areas. One of them is particle technology. So actually, we are in the laboratory for particle technology. On this subject, we study both fundamental and applied research. Fundamental problems such as the transport of solids. So in the past year of work, we have studied the pneumatic transport of solid, and using different kind of tomography image and the multi-phase flow modeling to study the dynamics. So this is on the fundamental side of research. On the more applied research, in recent years, we work on the subject of waste to energy and resources, where we handle different kind of solid waste and try to harvest the energy from it. So from here, I think this falls into the subject area of the renewable energy research.
Which modules you are teaching, and what is your favorite parts about teaching in NUS?
Yes, sure. Here in NUS, I'm teaching two subjects. Basically, the first one is heat and mass transfer. I have close to 290 students in the class. So I guess the most enjoyable part that I have is probably I can say is regarding a mini project where I ask students to pick up their daily life examples and try to provide some quantitative analysis on it. The other subject I'm teaching is particle technology, or also named fluid solid systems. So I guess these two are the main subjects I'm teaching at NUS.
So just now you say there's a few current projects you are conducting. Would you like to share more with us?
Sure. So on the subject of particle technology, as mentioned, so we work on the fundamental aspect of the particle transport. So coming to the way to analyze it, typically you have two different approaches. You can take experimental or simulation approach. So therefore, from this lab, you can see that we have different kind of tomography device. So this is set in the different section of this whole device. So this is one type of circulating fluidized bed. By using the principle of the permittivity of the material is a well-defined property of the material, we are able to use this to determine the particle distribution in particular handling devices. So I guess this showcases some of the work we have done over here. And on the simulation side, of course, it makes use of the state-of-art computational facility to calculate the two-phase flow transport. So I guess that's a brief summary of the research. So going from very fundamental to more applied research, quite often the flow conditions become more complicated. Therefore, more different type of driving force should be considered. So that will become a wide variety of problems of practical interest. Okay, welcome to the drug delivery lab. So in this lab, we work on different kind of project regarding the encapsulation of bioactive material into the drug dosage form. And different kind of method we use for encapsulation, including so-called EHDA, electrohydrodynamic atomization, or electrospinning. In brief, we use high electric field to fine regulate the process of drug encapsulation. Through the good engineering analysis of this, we designed the reactor toward this encapsulation. And other than the use of electric field, we also use supercritical fluid technique for the encapsulation. Talking about the application of the technology, we have been successfully developed different drug carrier dosage form for chemotherapy, radiotherapy, and for dental application in recent years.
So lastly, do you have any advice for the undergraduate students and postgraduate students in chemical engineering?
Yeah, sure. Quite often, our students they are encouraged to take some kind of research project during their study. So through the project work, so that basically they will learn something slightly different from the regular module we offer here in NUS. So the research project turned out to be more open-ended. So that gives students a different training to think in different dimensions. So I would highly encourage them to take out a research project, even though this is an option for the chemical engineering curriculum.